Hello, welcome once again to the Maths Jedi channel. This is another video in my A-level series. This one follows straight on from the video you've just seen prior, which is on distinct linear factors with partial fractions. This is partial fractions now with a repeated linear factor. If you're new to the channel, I really encourage you to look through the other videos available on my channel, and please do leave a like and subscribe to help us keep the channel going and to support us in forthcoming work. With regards to looking at this then, let's just focus right in on how partialised fractions work with repeated linear factors. Let's state first of all what kind of question you should be looking for. So you can see on this next screen we've got an example of that. Where do you see the differences between this and the previous video? Hopefully you can see it straight away. It has a repeated linear factor here, so x minus 3 squared. So it's called a repeated linear factor because this is a linear factor, but of course you've got two of them. So that's why it's slightly different. It's a slightly different method for working for these than in the previous video. So what you do in situations like this is you set up a set of situations where you've got a over x plus 4, so similar to before, b over x minus 3, but because you've got a repeated factor, you have to state a particular constant over that repeated factor. So c over x minus 3 all squared here. Now everyone always makes this mistake. They always think it should be x plus 4 and x minus 3 squared, and they always forget that middle constant. But it's important to make sure that you've got in your head the idea that it's effectively is three different roots. There's one root here, and this is two equal roots if you were to look at it in terms of roots. So that must mean that you've got three different factors on the top to go with those three different roots. So it's important to understand how this is created, and important to understand that you must never forget that it's three particular linear factors that we need here, because there are in fact three factors on the bottom, even though one of them is hidden away. In a similar way to before, it makes sense to equate coefficients or use substitution to work things out. So you just go through and work it out in a similar way. So for example, if we were going to multiply out to collate all this together, what would you multiply by a to make the denominators the same? You'd multiply it by x minus 3 all squared. You can see them doing it here. B, you'd multiply that by x plus 4 and x minus 3. And then C, because it's x minus 3 all squared, you'd multiply just by the x plus 4. So you can see them doing that here. So you can use substitution here. You can use x equals minus 4 to get rid of b and c to leave you with a. That's what they're going to do here. So they're using x equals minus 4. That gets you an a value very quickly. A is 2. Then you could use x value x3, because of course that gets you rid of a and b and leaves you with c. So they do that really quickly. And c is 7. But then to get b, they're going to switch into equating coefficients. You could do a similar method to the video I showed last time in terms of using a simple value of x, like 1 for example, or 0, and then that gets you a very easy expression that you can then substitute the values of a and bit c into to work out b. I actually prefer that method, but they're going to equate coefficients. Let's just look at them doing that. So they're going to equate the coefficients of x squared. So going back a tick, you might remember that on the previous question, the coefficient of x squared was 6. You can see here that once they've multiplied everything out, they're going to work things through as a and b, because they understood already that when you were multiplying things out, the a plus b was the coefficient of x squared, and they got that by multiplying everything through. So you can see we'll have a x squared term here with a b against it, and an x squared term here with an a against it. So a plus b will be the coefficient of x squared. They do eventually get the value of b is 4. And again, just like as before, you would write the fraction out as three partialised fractions. Here's another example. This time the repeated root is this first one. So you're going to have to write something over x squared, something over 4 minus x. So remember, this is the one everyone always forgets. So it's just that on its own, then the x squared, and then the 4 minus x. Remember, there's always three factors because there are three factors here, not just two. In a similar way to before, they've multiplied out and equated numerators, and then they're using substitution to work out what the values are. B is 3 here, and c is 4. It's a very simple example, but we'll see plenty of these in just a second. They're going to compare coefficients to get the a and c values understood. So they're getting a is 4, and then they're writing it out partialised at the end. So this is exercise 1E. This is on page 13 in the A2 book. we're going to work our way through a couple of these examples just to give you a good confidence of this. And again, just as before, I would encourage you to go through and work your way through the rest of this exercise in your own time to give yourself good, solid practice. So we're going to start off, I'm going to show, again, I'll probably concentrate on 6 and 2, just to give you a bit of a grounding of 2 different types, and then you can work your way through the rest in your own time. So looking at 2 first of all, it's giving you the values to use, so we'll work our way through those. I mean, it's quite nice that in these particular questions they're giving you a format to work to. You would expect that in the actual A-level exam they won't do that. They will actually expect you to understand what the partialised forms will look like. So it's important to recognise that you understand that there's going to be one linear factor over x plus 1, that's the one everyone always forgets, b over x plus 1 squared, so that's the repeated root, and then c over x minus 1. It's just a format you have to remember. Look for that repeated root and understand where it goes. In terms of multiplying out on the numerators, you'd have a multiplied out by x plus 1 and x minus 1, because we're trying to get from this denominator to this denominator. You'd have b multiplied by x minus 1, and you'd have c multiplied by x plus 1 all squared. Sorry for going over the page. You have minus x squared minus 10x minus 5 equal to all of this. And just like before, I'm going to use a bit of substitution. So let's look at the value of x that will get rid of some of this stuff. So if I let x be 1 first of all, that will get rid of a and b and leave me with c. So I'd have minus 1, minus 10, minus 11, minus 5 is minus 16. And this is gone, and it leaves me with 2 squared, so 4c. And that gives me minus 4 is c. And then x equals minus 1 will get rid of a and c and leave me with b. So let's do that. So I'm going to have minus 1 here, plus 10, so that's 9, and then 9 minus 5 is 4. And then this will be gone. This is going to be minus 2b. So that means that b is minus 2. And then just as before, I'm going to do a slightly different method to them. I'm not going to equate coefficients of x squared, although I could. I'm going to work my way through and just understand how to get a just by using a very simple substitution. So I'm going to let x be 0 just to work my way through. So if I do that, I'd have 0 here, minus 5. And then 1 times minus 1, so it's minus 1, so it's minus a. And then minus b, and then plus c. And again, because I know what b and c are, I can write an expression for that really quickly. Eventually you get the value a is 3. As before, you'd need to make sure that you've written everything out as proper fractions, so you can't leave it unstated. So a was 3, b was minus 2, and c was minus 4. So that's how your answer would look at the very end. Just box it off. There you go. Let's move on to number 6. So number 6, similar way really. So they're giving you again a little thing to aim at. This time the repeated root is x minus 3 all squared. Again, this is the one everyone forgets. Just make sure you don't. If I multiply it out, you'd have, what would I multiply by a to get these denominators the same? It's a lots of x minus 3 squared. What would I multiply b by? I'd have b multiplied by single x minus 3 and then the 2x plus 1. and then the c finally would be multiplied by 2x plus 1. Again, we're going to put values of x in, so if I wanted to get rid of b and c and leave me with a, I'd have minus a half. That would work. So let's do that. So minus a half gets rid of this one, gets rid of that one, leaves me with a. So you have to be careful with the algebra. So a half squared is a quarter, so 10 over 4. Two negatives make a plus, so that's going to be plus 5, and then plus 17 on the left-hand side, and then minus a half minus 3. So that's going to be minus 3.5, so that's minus 7 over 2 squared. That's going to get you 49 over 4. And you could use a calculator to do this for you, so I'll put up the calculator real quick to make my life a bit easier. Here's the calculator. So we're going to use the fraction buttons. So here, and then plus 5, and then plus 17, 49 over 2. So very quickly you can see a is going to be 2. Leave that there for a little bit. To get the value of b, we'll skip that for now. Let's let x be 3 to get rid of a and b and give us the value of c. So we're going to have 3 squared is 9, 90, minus 30 plus 17. Then that's going to go, that's going to go. That leaves me with this one. So 2 3s are 6 plus 1 is 7c. So that's 60 plus 17. So that's 77. So c is 11. So c is 11. Scribble that away. And again, just as before, I'll let x be a fairly simple value. So let's let it is 0, for example. So this becomes 0, you get 17. And then minus 3 squared is 9, so you get 9a. And you're going to get minus 3 times 1. So it's minus 3b. And then 1 here, 1c. So again, because we know a and c, we can corresponding substitution. And then I can just use some algebra to work it out. So 17 minus 18 is minus 1. Minus 1 minus 11 is minus 12. Very quickly you can see b is going to be 4. So those are all the 3 values that you need. As before, you would need to write them in to get a full answer. So you'd have 2 here because a was 2, b is 4, c is 11. That's how your answer would look. Hope you can see the 11 part. It's a little bit hidden away. But that's how your answer would look. Okay, so going through these things is very simple. Just make sure that you've understood how to substitute in appropriately and to where to do it. The key thing is with repeated roots, you don't forget that there's a single fraction for one of those repeated roots that everyone always forgets it. So in this case, it's this one. Everyone always forgets those ones. So make sure that you remember that's what repeated root situation should have. You should have 3 factors to match the 3 partial fractions to match the 3 factors that you have in your particular problem. I'm just going to check the answers real quickly before I go, just to make sure that we're on the right track and that we have those things right. So let's just do that. And you can see here, oh, it's actually on number 6. So a is 2, b is 4, and c is 11. So you can see that working through. I think the other one we did was number 2. So D and F, yeah, so D was 3, E was minus 2, and F was minus 4. So those are the values through. It gives you a check. As I say, I would encourage you to do the others in this exercise before you're finished with this particular method of partial fractions. The next video to come will be on improper fractions. So what you do when you deal with improper partial fractions, or when you're partializing a situation with improper fractions, that will follow on next time. But for now, and for this video, thank you very much for watching. Goodbye for now. Bye-bye.